Hello, thank you for watching this video. So in this video, we're doing question 9 of May, June 2023 question paper mathematics paper 1, paper 2 actually. And the topic is Euclidean geometry or cyclic geometry, as you can see here. So we continue, and all of the content that I've done here, that is on this question, is on the back action sessions. Go to my playlist and watch my teaching lessons where I'm doing these kind of things, right? So let's go. They are saying in the diagram, O is the center of the circle. A, B, C, D is a cyclic quadrilateral, right? No problem. They are saying use the diagram in the answer book to prove the theorem which states that opposite angles of a cyclic quadrilateral are supplementary. Prove that, which is, in this case, they want you to prove that the sum of angle B and angle D is equal to 180 degrees. So they want us to show that this angle and that angle, they add up to 180 degrees. Want us to prove the sum of these two angles here is equal to 180 degrees. That's what they want us to prove. No problem. So how do we prove this? So I'm going to do it slightly different from what I've done on my bed actions, right? Just to make it a bit exciting. So this is how I'm going to do it. Let's do it this way. Because if you are doing these questions, I'm assuming that you have studied everything, right? And also these are grade 12 question papers that I'm doing here. So which means you've done this at grade 11. So this is what I want you to remind you. Let's say you have a circle here, like this. We did it on the previous question. And maybe you have some sort of a triangle inside, like this. Right? Let's say you have a tangent to the circle there. You have a tangent. This is a tangent to the circle. So I want to remind you of the tan-chord theorem. What does the tan-chord theorem say? It says the angle between the tangent and the chord is equal to the angle that the chord will subtend on the other side, right? Which means the angle between the tangent and the chord, which is this angle here, is equal to the angle that this chord will subtend on the other side. So this angle here, theta, will be equal to that one over there. In a similar way, if you're saying this is a tangent and this is the chord, if you're saying this angle is beta, which is the angle between this tangent and the chord will be equal to the angle that this chord will subtend on the other side. This angle will be beta as well. That's what I want to do. I just want you to remember this. So let's go to this one. So I want to prove that the sum of this angle and that angle is 180 degrees, right? No problem. Let's construct something. Construction. So the first thing that I'm going to do, I'm going to join. Let's join AC. I'm going to join AC. So there's AC. Join AC. So after joining AC, do you see that I have a triangle here, similar to that? And I have another triangle down here. So I have two triangles here. I have two triangles, this triangle here, and that triangle up there. So you have two triangles, this triangle, this triangle. Okay. The next thing, what do we do? The next thing, we want to draw a tangent to the circle. We want to draw a tangent to the circle. So it's up to you. You can draw it at C or at A. As long as it's not going to be these that you are trying to solve. You can draw a tangent here at A, or you can try a tangent at C. So let's draw our tangent at C. Draw a tangent, and let's say draw a tangent. Draw a tangent, let's call it TCN at C. We're going to draw a tangent that we call it TCN at C. So, alright, there you are. So let's say we have T, we have N here. Then we can say this angle, now the angle from here to here, we can call it C1, this entire angle, which is the angle from a tangent to AC is C1. And this angle over here is C2, this entire angle over here. Maybe I should have used the right ink. So this is C1 over here, and this is C2 over here. right? No problem. So if you apply your tan chord theorem, you can see that C1 is called angle D because of the tan chord, because the angle between the tangent and the chord, AC is a chord, the same way there. So angle C1 is called angle D. So I'm going to say, okay, angle C1 is called angle D because of the tan chord, which is the tangent, TCN, and chord. Our chord is AC, right? In a similar way, we can say angle C2 is equal to angle B. C2 is equal to angle B. In a similar way, this is a tan chord. Tangent T, CN, and chord AC. Right? No problem. But look now, if you add C1 and C2, they'll give you 180 degrees because those are angles on a straight line, right? So in this case, okay, C1 plus C2, they give us 180 degrees. These are angles on a straight line, so they give us 180 degrees. But look now, C1 is equal to D and C2 is equal to B. In that case, we can say what? We can say, instead of C1, let's substitute our D plus C2, let's substitute our B. This will be called 180 degrees, which is what they wanted us to prove. And we're done with this proof here. We're done with this proof. 5 marks. Done. Now, I'm going to draw 9.2 and we'll do 9.2. So let's go. Okay, so now we're doing 9.2, right? 9.2 read as follows. They are saying in the diagram, DEFG is a cyclic quadrilateral such that EF is parallel to DG, H is another point on the cycle such that DH is parallel to FG. Chord EH is drawn. Let D equal X. So they are saying, prove, giving reason that D1 is equal to D2. So they want us to prove that this angle D1 is equal to D2 over here. So let's try to analyze this. They are saying DEFG is a cyclic quadrilateral such that EF is parallel to DG. DEFG, which is this quadrilateral here, is cyclic. What does it mean to be cyclic? Which means all of its vertices lie on the circumference of a cycle. You can see D is on the cycle, E is on the cycle, F is on the cycle, and G is on the cycle. That's what it means to be cyclic. Then they are saying that EF is parallel to DG, which is EF is parallel to DG, which is two sides of this cyclic quadrilateral are parallel, which means your quadrilateral or DEFG is a trapezium because only two sides are parallel. So that's your trapezium, right? Fine. They want to say H is another point on the cycle such that DH is parallel to FG. They're saying this is the point on the cycle so that DH is parallel to FG. Fine. They're saying EH is drawn with EH. That EH to complete the quadrilateral. And they're saying allow D1 to equal to X, which is they say let D1 equal to X. So they want us to prove, giving reasons, that D1 is equal to D2. So they wanted to prove that this angle here and that angle are equal. So look, if we add D1 and F1, they will give us 180 because we just proved this on 9.1. Those are opposite angles of a cyclic quadrilateral. If we add F1 and G, they will give us 180 because those are co-interior angles on parallel lines. If you go to the playlist, watch my back action sessions, you will know all of this because I've taught it there. I was teaching some students, so you should understand it very well. So, if D1 and F, they gave you 180 degrees because those are opposite angles of a cyclic quadrilateral. Angle F, that's angle G, they give you 180 because those are co-interior angles on parallel lines. Because you can see angle G and angle D2, they're equal because you can see these are corresponding angles because these FG is parallel to DH. And you're done with this. So let's go. So in this case, you can say, okay, look, D1 plus angle F is equal to 180 degrees. Why? These are opposite angles of a cyclic quad, right? No problem. Now, let's say angle F, this angle plus that angle F plus angle G. This gives us 180 degrees. Why? These are co-interior angles on parallel line, right? Because these are co-interior angles on parallel line because this is parallel to that, which is your EF is parallel to DG, right? So look now. On F, you added D1, you got 180. On the same F, you added G and you got 180, which means this G and the D should be the same. Look, you said F plus D1, it got to 180, and you said F plus G gives you 180, which is these are the same. But okay, if you don't see, we can say D1, we can say 180 is equal to 180, right? Which is this side equal to this side. So is this side, which is your D1 plus angle F is equal to angle F plus angle G. So this and that go away. Get that your D1 is equal to angle G, right? Which is what I'm saying. Because if you're adding D1 to F and get 180, and you add G on, sorry, you add D1 on F, you get 180, and you add G on F, you get 180, which is these two should be the same thing. As you can see, they have done that. But look now, this G here is the same as that D2 because these are alternate angles. So look now, we can say now the same G is equal to D2. Why? These are alternate angles on parallel line, on parallel lines, because your DH is parallel to FG, right? So look now, your D1 is equal to G, and this G is equal to D2. So these two things should be the same as 1 because of the transitivity of equality. So you can say, therefore, say D1 is equal to G, and the G is equal to D2. So all of these three things are equal. Therefore, D1 is equal to G, which is equal to D2, which is what we want to prove. We're done here, which is what they want us to show. This is equal to that. Because they're both equal to the same G, so they should be equal. Right? And I'm done with this question, and I hope it does make sense to you as it does to me. Thank you for watching. I'm going to do the last question, which is question 10, and we'll be done with this question paper. Cheers.